Good morning, especially after the night, like tonight. I don't know where you live, but I was trying to sleep, and all the time I heard like doof, 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 ptsh. So yeah, I feel like super energetic today. I was asked to prepare a very lightweight and very intro-level talk. So at the end, we will see if I succeeded. The topic is navigating app security, and we will discuss the defensive security and how to build security controls and how to work with teams. My name is Anastasiia, and I'm head of security engineering at Cossack Labs. Here is me in 2019. Do you know where it is? I'm sure you can recognize the place. Yes, that's Apple Campus. Yeah, in California, it was nice, but when I found this photo yesterday, I was like, oh my God, it's already like 5 years. Time passes. So what do you do? At Cossack Labs, we are a data security solutions company. We are like more than 10 years old, and we were created in the UK and Ukraine, and we work on creating security for other companies that have elevated security requirements. We work with fintech, we work with AI ML, we work with large industrial complex like power grids, like electricity, and lately we work a lot with robotic and autonomous devices. Since 2022, as a company, we are supporting Ukrainian defenders a lot, and a lot of our work has translated into how we say it, mission-critical work, because I'm not allowed to say military on the stage. So yeah, as I mentioned, I was asked to create a very intro-level talk. So this is what we're gonna talk today. Yay! Okay, do you know what all these things, what they mean? At least one of them. Just raise your hand if you recognize at least one of them. Okay, I see hands, perfect. So yeah, that's the plan. At least you know at the end of this talk that you will learn more this weird abbreviation from the security world. Technically, we will speak on how to define which security controls to build in your applications, how to basically build them, which processes we can use, how to measure security to understand if the security posture of the application is good enough, and what to do with those measurements. Okay. One of the often questions is what we are building when we are talking about security. And there could be a lot of answers. Not every application needs security, right? We can work on applications like Instagram for cats, like for kittens, and maybe its security needs are not so high as for application that controls power plants. Right? So when we are discussing what to build, it really depends on the risk and threat models. Here on our website, for example, you can find case studies of some public applications that we built in security measures. And in every of these case studies, we first start with explaining why we are doing it, what risks and threats we are facing, and what security controls we are selecting to mitigate against those risks and threats. Also, if you are wondering, I want to be a security engineer or I want to be a better developer, what should I pay attention to? How to understand that these are the things that I need to know? Another example might be our blog post, where we post a lot of defensive security things, a lot of our research or our ideas, how we are protecting applications, and like certain things and tips. So my point here is that if you want to think which security measures to build, you don't need to reinvent the wheel. There are already a lot of materials, a lot of information in the web that will allow you to read, inspire, and select security controls. But if we want to be a little bit more serious, we can take a look on this plan, which I call Application Security 101. It's based on NIST RMF, which is Risk Management Framework. Yeah, intro-level talk, I remember. So basically, I will walk you through this. When you start from, here is my application, what security controls should I build? The first question is, does my application need security? How much, if we can say so, security does it need? Which means that we identify risks and threats, we try to think what worse can happen, what are the outcomes, who will be attacking us, like how much we should invest into security. Should we just maybe do a pen test once a year, or should we build in security features together with the product features when we are building our app? Then you want to understand what exactly are we protecting, or data classification, like assets classification. What we are protecting, what kind of data, where this data is stored. Often mobile applications and desktop applications, they are part of the bigger system. So when you're talking about data protection and data classification, you want to build a data flows from the application, from the client side, mobile side, desktop side, to your backend, if you have any, right, and back. Looking on the data flows, understanding data types allows you to understand like risks and threats associated with them and select security defenses. And these are the three items that we will focus on today. What security controls to build? When you understand how much security you need, what you are protecting and from whom. Next question is what we are building from security perspective. What are the security features we want to implement? Then how we can implement those features during the product development, when the team needs to release application every 2 weeks, etc., etc. Where is the time to build those security features? And then how to check, how to validate, how to assess if we build security features good enough, if our implementations is okay. And of course, rinse and repeat, because application security is a process that does not have an end. Okay, to simplify this list, we can just ask ourselves 3 questions when we're building the app. Once we understand that we really need security in our app, what security controls should I build? And we can take a look on the numerous guidelines, best practices, and standards. Then, how to build them, and we can use another standards for processes, for security life cycles, and then how to assess them. We will take a look on validation frameworks and another set of standards here. Again, you don't need to reinvent the wheel. A lot of things are already described, they are already put in the internet. And my message here is that if you're new to application security, to defensive security, you already have a lot of places to start with. This is like a basic security, a baselines. And then once you implemented your baselines, you can go deeper and invent your own security controls. Don't invent your own cryptography, but invent your own security controls and think about more specialized things. Awesome. So, what should we build? Apple has a lot of guidelines for that. For example, this one. These are the talks from WWDC, and this is what Apple, these are specific topics regarding security and privacy that Apple teaches us as developers. And I'm sure that you're watching certain talks every year at every WWDC, right? Yes, Anastasiia, of course we're watching security talks, obviously. Someone is publishing those for us. If you're a user, Apple has another guidelines, Apple Platform Security, which are only 265 pages long PDF. This is a PDF where Apple explains how Apple built things for you as a user. I really recommend reading it if you didn't have it already, because it explains a lot of concepts that you can then use in your own applications. And of course, the next point, when you understand that Okay, you have a place where you can read and be inspired what security controls to build. Then the question is how to build it, because no one wants to build in security features. Developers want to develop code, product managers want to ensure that releases are on time, an application has all these nice features. No one wants to spend time on security, so how we can make them? We can create a process and say, hey, you are not just addressing the security, you are following the process. The process is called SSDLC, or Secure Software Development Lifecycle. Have you heard about this before? Are you familiar with this thing? Yeah, you are not a student, sorry. I see you. Okay, so SSDLC says that instead of doing security at the end, when your application is ready, you want to do security starting from the first steps in the applications, right? You want security features to go hand by hand with your product features, with your application features. The idea here that you kind of shift in security left. I'm sure you have heard this term. Shift security left means that we spend more time on security in the early days of development. In this case, we try to eliminate the root causes of popular bugs or popular vulnerabilities. We try to put mitigations and security defenses to prevent bugs from happening, which means that when our application is released, there is lower chances that someone will find security issues or exploitable things in our app. There are different frameworks that describe and explain SSDLC. NIST has its own, this is fresh new NIST SSDF, Security Software Development Framework. OWASP has their own explanation and description, OWASP SSDLC. Microsoft has MS SDL. Even PCI has its SSLC. All those frameworks, they basically focus on the same idea, how to build in security into your application cycle. They use different names and they have different stages in the flow. We will focus. I will show you the NIST SSDF steps here. When you are building an application from not talking about security, you want to understand what features you're going to build, what are requirements, what users want to see in our application, right? Requirement gathering. Then you want to design, to architect your application. What will be the modules, what will be the components, how these applications communicate with the backend, architecture. Then you develop, you test, you deploy and enjoy, or fix bugs and start again. From security perspective, we just say that we add security relevant things on each of those steps, right? Instead of addressing security at the end, when application is built, and suddenly you have a lot of security issues, you want to do it on every step. You want to work with security engineers on requirements gathering, during architecture and design. You want your security engineers to help your software engineers to write better code. You want security engineers to validate, to assess, to help you with testing, and of course then to check if the thing that is deployed is actually secure. Does it make sense? Yes, Anastasiia, of course it makes sense. What? No, of course. Why? Why bother? Okay, let's imagine that you bothered and actually implemented certain security features in your app, even if you don't follow SSDLC. You just, being a good developer, you wanted to implement certain features. How do you measure if something that you have implemented is actually good enough? There is another set of frameworks for that. Again, everything is already invented. These are our... Okay, please raise your hands if you have seen some of the things before. Okay, I at least see a couple of hands. Okay. So you know that OWASP is a large organization. They were focused on web security, but now they have guidelines about everything. So OWASP MSVS is Mobile Application Security Verification Standard. OWASP ASVS is Application Security Verification Standard, and OWASP SAMM is Software Assurance Maturity Model. All these three are basically they're huge checklists. They're huge frameworks that have a lot of requirements to help you to validate and assess if your application complies to those requirements. When we're talking about mobile, we will use MSVS. When we're talking about desktop, like macOS application, we will use none of them because OWASP does not have a good guidelines for desktop applications. Maybe fortunately, maybe unfortunately, but we can use a mix of MSVS and ASVS. We at Cossack Labs, we use MSVS a lot, but recently the MSVS team, they have refactored and they have changed the framework, and we decided that we don't really like those changes, so we created an extension and made it public. And often what we use when we do security assessments or when we do security validations, we use an extension on OWASP frameworks called CLMSS, which is Cossack Labs Mobile Security Score, which is basically an extension above MSVS, which has even more security requirements, because we are usually dealing with applications that need more security and that have more serious risks. So CLMSS is a framework that has 157 requirements. Of course, not every application should comply to every point, right? This was our question number one. How much security should I have? What risk and threats my application is facing? Is it a remote control to a nuclear facility? Is it Instagram for kittens, right? Similar to OWASP MSVS, in CLMSS we also split the requirements by different levels. Level 1 being basic security things, those security controls that will cover against most risks. And level 2 being advanced security things, security controls focused on exact attacks or just things that may be complicated to implement. It's public, it's available on GitHub, and it's just an extension on OWASP MSVS. If you used MSVS enough, you understand its limitations, and you want to go deeper, you can check it out. I will show you a couple of examples, and I will show you how the requirements is translated to security control. As I mentioned, it's just a huge checklist, right? In security, we often operate with a large checklist. Here is a video of one application. You see a lot of green, a lot of yes. This application was already assessed. Its results was not so great, but the team has implemented a lot of fixes. So in many cases, when we checked again, the requirements that were not successful became successful. So the app actually has really nice security posture. When working with such frameworks, you want to read the requirement. You want to understand what it means, because some requirements are they go very deep in your app. You want to check if the application actually has those features or protects against those attacks, and then you put yes or no. Once you checked across different areas, you have your security scores. Let's take a look on some examples. Similar to OWASP MSVS, one of the focuses in our applications is architecture and privacy. Right? What we found out from privacy perspective, that one of the very usual issues is that screenshots that developers post in the App Store contain sensitive information. This is an example. This is not a real screenshot because it contains sensitive information. But the idea is that one of security controls, one of the requirements is to check if application that is available in the App Store has sensitive information on screenshot. You won't imagine how many apps, when they're preparing screenshots, are actually use the data of the user. In many cases, this is a developer or a product manager with their own information, with their valid email, and put those screenshots in the App Store. Another example of security control would be would be authentication chapter. Again, you see how it looks like. This is a part of authentication chapter, requirements starting from 18 to 24. And you see they are divided by levels. Some of them are easier to implement, and they are basic security. Some of them are more complicated to implement. For example, this one. That your application needs to detect if system biometry has changed, if user has added another, changed their Face ID or added another Touch ID, and as the application needs to invalidate the biometric protection and ask user to re-authenticate. This is one of the level 2 requirements because not every application needs this, but it's a really good idea when you're working on more security-sensitive apps. And how we do it in iOS, of course, we are looking at biometric current set values. Right, here is a docs for that if you don't know how to do it. And we can ensure that we don't trust the user anymore if they change the biometric settings, so we want them to re-authenticate. Another chapter here, similar to OWASP MS-WAS, is reverse engineering protections. Reverse engineering protections is something that we can start and go on, especially on this, on these talks today, because many of the speakers know a lot how to reverse engineer the apps. And trust me, any standard won't protect you from someone who wants to break your app, right? But if you want to protect against low-skill reverse engineers, it's a good idea to implement at least certain features in your app. For example, Apple has built-in frameworks like Apple App Test and Device Check. It's the same framework, with different chapters in it. The Apple App Test framework allows you to verify if your application was indeed installed from the App Store. And inside the app, you can trust user or don't trust user based on this information. But then, which is more interesting, you can double check. If your application has a backend, you can double check if the application says it's been installed from App Store, and if Apple says that this application was installed from App Store, and decide if the user actions look like malicious or at least suspicious. Right? So Apple has a lot of ready-to-use frameworks and controls that will allow you to go through those requirements and satisfy them. Okay, do you know what it is? It has a hint on the first line. Yes. Okay, that's a keyboard cache. So you know that one of the requirements in OWASP MS-WAS is that applications should disable keyboard cache on certain fields. And in many examples, in many use cases, the keyboard cache is disabled. But if you're creating a field that user will use to input some sensitive details, their password, for example, for the password, iOS actually has already disabled the keyboard cache, but if you create in your own text field and you want the user to input something sensitive there, it's a good idea to disable keyboard cache, because everything that you enter in your text field is stored in the database and can be accessed. Nice, right? And this is level 1 requirement, which is a basic security requirement, which is a good idea to have in your application, but that's the easier one. Okay, let's imagine that we went through those huge checklists. We went through those requirements. We implemented certain security controls. What next? We want to measure things, because security should be measurable, because when people will ask you, how secure is your application, what you will say? you want to calculate something to compete. We suggest calculating security scores, which is an obvious idea, because if you have a huge checklist and you select items that your application has, right, you select security controls that your application satisfies, security requirements it satisfies, you just put yes, 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 and you just can calculate the number of those yeses. So we use those security scores to measure the security posture, and you see on the screenshot we like to measure for both levels, because advanced security controls level 2, they are more complicated and usually they take more time to implement. But basic security controls, they're quite easy, and that's okay for application to comply, like to have 80% of security scores. That is typical. Then most standards, like OWASP, they have different chapters, and I was showing you examples of requirements from architecture, from authentication, from resilience, right? And you can measure how good your application is for each of those chapters. What you do next? When you did a first assessment, you measured your first security scores. You calculated all good and bad things in your app. You worked on improvements, and then you measured again. Here is an example. This is one of the applications that we are working for many years already, and you can see that we are measuring its security posture every year. Well, we measure it more often, but in this screenshot, you can see measurements every year. The applications, they are not some static things. They are always growing. Developers change something, they refactor some pieces, they add new features. So in this example, you can see that the cryptography started 2 years after we started doing like security assessments and helping them with security. Only then, here, we worked with those developers to ensure that they have good enough data security and cryptography. Then you can see in some cases, like a platform, you can see it was higher, but that it gets lower. That's okay, because probably they have added a lot of new features in the app without doing any security things, so the scores go down. This is a very nice thing that to show to managers, to show to security engineers, to show to auditors, to show that you don't only do some chaotic security things, but you actually measure and you control the process. So, let's wrap up. When we do think about using security standards and measuring security posture, measure security scores, we usually do it because our applications need security. Why our application needs security? Because usually we protect our users, we protect our data, and we protect our reputation. Do you know that in some cases, even if the application doesn't have a lot of sensitive information, the breach, the security incident, can have a lot of reputational issues and outcomes for you as a company that created the app, or you as a developer, right? Then, of course, we want to calculate security scores to understand what is the current state of our application. If the application is being actively changed, do we introduce any security regressions while we're working on new features? If application is in maintenance mode, is it declining? Is its security posture declining as well? Another good idea is to use security scores, which we like a lot, to negotiate with product managers, because product managers want to implement a lot of features. They don't want to implement security. So what we're saying and showing to them is the security scores, and we say, hey, security scores are going down. We need to do certain security things to ensure that our application doesn't get really bad from security perspective. And if you have a lot of applications, or if you have a lot of teams, security score is a nice metric to compete against those teams. We work with certain products that have like web application and mobile application. And those teams, they compete how secure is their app and show to each other what new security features they implemented. So having security scores is really a good idea to push your security from, from pen tests, from reaction on incidents to proactive, to defensive, to implementing security early on. And of course, it's really fun when you're a security engineer to do assessment and say to your developers that, sorry, those things need to be re-engineered and re-implemented. Yeah, this is why we do our job. That's all. Thank you.
Thank you so much. That was incredible. Please, do you have any questions to Anastasiia? Please do ask them. Oh, yeah, I see.
So is OWASP, MSVS, and CLMSS frameworks are purely security-driven, or they take a glance at efficiency of usage of apps by users, meaning developers and security teams can evaluate both efficiency and implementation of security requirements at the same time by using these frameworks, or they need to do it manually? So like they evaluate and think, well, we can cover the whole level 1 requirements and only a quarter of level 2, because otherwise it will increase times of usage from the user by 2 or 3 times.
Okay, so what you're describing is the process of scoping and tailoring the security frameworks. When you have a security framework, first you want to do is to scope it, to cut everything not relevant to your application, right? Because, for example, if you have application that doesn't have user authentication at all, you just cut the user authentication section and don't do any checks related to that. Right? This is step number 1. The step number 2 is scope, is to tailor. You did the scoping, then you tailor. You try to understand what are risks and threats in your application, and what of those chapters or security controls are relevant for your application. Because not all of them are relevant for you. Then, once you you want to make your job easier and you want to make this framework smaller. In most cases, you don't need all 157 security requirements. Once you did that, then you can decide if your application has high risks. As you mentioned, you can start with level 1, and that's okay. If your application has, like low risks and security, you just start with level 1 and you will be fine. If your application has high risks in certain areas, you want to do chapters with level 1 and level 2. You want to go deeper, right? So the framework, it does not say you like what to do or like how to do or in which priority and order you can do things. It just gives you a lot of to-dos, and it's up to you which of them are relevant to you and what is the order for you to do to implement them. Does it make sense?
Yes. So it means that I will need to continuously evaluate and review the scope. For example, I review the scope, implement level 1 requirements, and review it again to ensure that all security baselines are covered and the efficiency didn't increase or decrease and time increased for the usage.
Yes, you can say it so, yes. In some cases, instead of implementing certain security requirement, you can just say, no, we will not do it because it will ruin user experience. Right? It means that you accept the risks of not doing it. You understand the consequences that not implementing this feature can cause an incident, right? But you accept those risks and you just don't do it. And in framework, you put that you have accepted the risks and you can reevaluate this in 6 months, in 12 months. right? So yes, as you mentioned, you can go through the framework again and again, but usually those like a large period of time, 6 months, 12 months, it depends on how fast your application is moving. And yes, you use this framework not only to basically implement things, but also to say, I will not implement these things right now because of reasons.
Thanks.
Awesome. Any more
Thank you
questions?
for the question.
Yeah, any more questions, comments, concerns?
Yeah, thanks for the deck. My question is about the bar for the security application. As you said, like kittens, Instagram for kittens is one thing, and the banking application is another. How to set their like decent amounts of persons after the assessments? We need to think about like how to. What is your recommendations?
Well, from our experience, for applications that don't have a lot of security requirements, implementing 60% of basic, of level 1 basic security is good enough. For applications that may have more elevated security risks, the basics should be above 80. In our experience, a lot of apps have 80, 85, 90% of basic security, like satisfying basic security requirements. With advanced, it's a little bit more complicated because they're advanced, right? Sometimes you just cannot implement them. But like applications like mission critical applications, they usually have like 90% of basic and 70-80% of advanced, because all those frameworks, they are baseline frameworks. They are things to start from. They are definitely not something that will describe all security features or all security controls. So this is just a starting point. It will take 6 months, maybe a year to achieve those results, but then you can go deeper. Then you can focus on something more relevant to your app.